Hello everyone, my name is Mustafa and I'm a medical student passionate about AI. Today I'll be presenting to you a very interesting presentation about a review article that was published in March 2022 by Iyad Elian et al. In the journal Artificial Intelligence Surgery. Now, if you don't know about this journal, Artificial Intelligence Surgery is one of the leading journals concerned with AI in medicine, and it places a special emphasis on the applications of AI in surgery. Now, with the guidance of my great mentor, Dr. Heba Tahir, consultant of pediatric surgery and a great advocate of AI, who also happens to be an editor in the journal, we've decided to make a short and hopefully informative video presentation of this great article. We've included the link below so you can scan the QR code and follow along with us as we continue this presentation. Now, before we get into the paper, we just need you to realize the importance of this topic. Many of us healthcare professionals today do not fully realize how AI is disrupting the healthcare scene, and most of us think that it's something from the distant future and that we won't witness it in our current generation. But the fact is, AI is already actively used in healthcare, and estimates suggest that around 30% of healthcare facilities around the world are using some sort of AI. Another estimate also suggests that around 1 million medical images are being analyzed on daily basis by AI models. So if you think that AI is still far away, well, think again. That's why it's important for us to have some basic knowledge about this technology and how it will impact us and how it will affect the treatment of our patients. Now, the paper focuses on computer vision, which is one of the tools of AI concerned with visual perception. If you don't know what AI means, it's defined as any computer system or algorithms with the purpose of performing tasks mimicking or requiring human intelligence. Computer vision is achieved by a process called machine learning, which basically involves feeding algorithms huge amounts of data and letting it make assumptions based on common patterns found in this data. Now, as you can guess, this amazing technology could be applied in many different sectors other than the healthcare sector, such as in agriculture, in law enforcement, and in manufacturing, and many other sectors. It's also worth noting that the idea of computer vision is not entirely new, as it traces its origins back to the 1960s, where it was used in a much more basic form. Now we will discuss how computer vision works from a technical point of view, and we'll try to make it as simple as possible. So computer vision actually is conducted in two ways: the old traditional method and the more advanced and more elaborated deep learning method, which we will discuss in the next slide. The process starts by inputting the data, in this case the images, into a program that extracts the features of interest from these images, say for example a white opacity on a chest x-ray. Then the processed data is fed into a machine learning algorithm which have been trained to give a meaning to the extracted features. These algorithms will also compare all the images being fed into it and will then make an assumption based on what it had been trained to identify and the images that we've introduced into it. So this is called the output, which is the assumption that the algorithm will make. Now, the problem with this process is that it has a very high margin of error if the images fed into it have slightly different conditions, like brightness, resolution, or a different angle of view from the images it was trained on. And hence, it's not effective in making the right decisions in a much bigger data set with a lot of variations. Another problem is the fact that feature extraction in this traditional method is a manual process that needs a human being, hence making the process much less autonomous. Now, all these challenges had led to the development of a new set of algorithms, a new architecture, that's what we call it, deep learning and convoluted neural networks. It was developed in 2010, and since then, computer vision has greatly advanced. So, with these newer methods, the whole process is done in a much faster way without the need of manual feature extraction. The algorithm is also capable of extracting the features in a much more autonomous way, requiring less human involvement and giving much better accuracy regardless of the variations in the data that was fed. We can briefly say that with the recent advances in computer vision and its wider use in medicine, all these recent advances can be traced back to three main factors. The first is, as we've said, the development of deep learning and convoluted neural networks. The second is that now we have more access to a higher quality and much bigger data sets. And the third is that now that we have much more powerful computers capable of doing all these hard, complicated processes in a much faster way. So this is what we call the formula of success for computer vision in medicine. Now, in this part, we were going to talk about computer vision and its use in medical imagery. So now you can think of computer vision as being a smart magic lens capable of understanding and analyzing images or videos. Since its recent advancements due to deep learning and convoluted neural networks, it has been a game changer in medicine, and it could be used in a wide range of applications, from assisting radiologists in viewing radiographs to helping guide surgeons in complicated surgeries to screening for mental health disorders, which is actually very interesting. So the main tasks of computer vision in analyzing medical imagery could be broadly classified into three categories. The first is classification, the second is recognition, and finally segmentation. We will now discuss each one of them separately. So, classification is one of the most essential tasks of computer vision. It's used to label or group certain images with specific findings under the category corresponding to it. As you can see in this example of a chest X-ray, the algorithm identified the lesions in the first radiograph as ground glass opacities and the second as consolidations. And so you can imagine how helpful this tool can be in such cases. This is all due to the latest development in deep learning and convoluted neural networks, which has made the diagnosis very accurate, and in sometimes it could be much more, even more accurate than the human being. So it has a huge potential to be used, but currently it's mainly used for tumor detection on mammograms as well as for the detection of skin cancers from dermoscopy images. Interestingly, classification can also be used to analyze thermographs and is currently being developed to screen for some malignancies, vascular diseases like carotid artery stenosis, and mental disorders. The next main task of computer vision in medicine is object detection, which is a relatively straightforward task. Briefly, the algorithm is taught to identify the normal, and so when there is an abnormality in an image, it can identify it and mark it with a bounding box for the radiologist to see. This could be used in conditions where findings are not very evident with the plain human eye. So in this case, a pre-trained computer vision algorithm could greatly help the radiologist. The main issue with it, however, is that it greatly depends on an experienced practitioner to initially label the features of interest and teach the algorithm what is normal and what is abnormal. The next and last main task of computer vision in medicine is segmentation, which, as the name suggests, is the process of segmenting an image into different regions. It helps visualize specific regions or anatomical contours of an organ, and it could be used in preoperative planning. It has also been used in cardiology to determine the complex intracardiac anatomy through echocardiograms and MRI image analysis, and it has the potential to be used in the early detection of pulmonary hypertension. So that's also pretty interesting for cardiologists. In this section, we will discuss the challenges faced in computer vision and all what needs to be tackled to make it progress and make it more widely used in medicine. So, as much as computer vision has greatly advanced in the last 10 years, it still faces many challenges that prevent it from being more widely used in medicine. So, these challenges can be broadly classified into challenges that are inherent to computer vision in general, and that are not specific to the healthcare sector, and challenges that are specific to the healthcare sector. So, inherent challenges with computer vision in general that make it less accurate are issues with data quality. For example, many data sets could have variations in image quality and resolutions. Some images could be taken from a different angle, some could be occluded with impurities, and thus this makes it harder for the machine learning algorithms to make accurate assumptions and learn correctly from these data sets. Now, the issues that are specific to the medical sector, mainly we have the issue of data availability. So generally speaking, medical imagery from patients is only collected when a patient is suspected to be ill and is indicated for an investigation. And thus, it's carried out in what we say an opportunistic manner. So it cannot be carried out with the primary intention of collecting it, as this is not feasible and it's really not logical. So another problem also is the difference between different imaging machines with different qualities of images, often leading to confusions for the computer vision algorithms. And the third problem is that in many instances, patients with the same disease could have a different presentation of that same disease due to the diversity in the patient's health condition and the demographics. And so, computer vision algorithms struggle to make proper generalized assumptions from this variable data. So, data bias is also a unique challenge faced by computer vision in healthcare. It's due to the lower prevalence rates of some diseases, so it's hard to collect data proportionately, and in a specific data set, imagery of a healthy individual will outweigh those of the diseased one in case of a rare disease, for example. So this will create a disproportionate data set, making the algorithm favor recognizing healthy individuals and healthy images, and making it also less accurate in recognizing the diseased or the abnormal images. So this is a natural phenomena in healthcare, and it cannot be stopped by collecting more data, as the problem will still occur. Instead, new ways are being developed to tackle this problem, like oversampling or undersampling. Now, the last main challenge faced by computer vision in medicine is explainability. As there is a strong medical legal need to make AI safe and trustworthy for use in medicine, so there's a need to make the algorithm's decisions easily explainable to the patients and their doctors in order for computer vision to be more safe and more widely used in healthcare. So, to conclude what we've said, computer vision has witnessed an unprecedented growth in the last decade, which could be attributed to the latest advancements in deep learning and convoluted neural networks, more widely available and better quality data sets, and the stronger computers that we now have. Challenges, however, still exist for the wider application of computer vision in medicine, and they will only be solved with the proper collaboration between medical practitioners and AI developers. Thank you, and we hope you've enjoyed this presentation.